Just 1 gram of this substance can release more energy than the nuclear bombs dropped on Nagasaki and Hiroshima. Combined. I'm talking about antimatter.
Hold up. You must be thinking, what is antimatter? How is it different from regular matter? Well, matter and antimatter are identical in almost all respects, except the most fundamental, its charge. For example, here is a hydrogen atom in which we have a negatively charged electron spinning around a positively charged proton. In an anti-hydrogen atom, we have a positively charged anti-electron moving around a negatively charged antiproton. And when matter and antimatter come together, they annihilate each other, releasing energy in the form of gamma radiation, true to Einstein's equation, which states that the energy released is equivalent to the mass times the speed of light squared, which is why so much energy is released for such a small amount of antimatter. Antimatter's existence was first hypothesized by physicist Paul Dirac, who in 1928 came up with this equation to calculate the speed of an electron using both special relativity and quantum mechanics. But he always got two results, akin to how the root of 4 yields +2 and -2. One of these correlated with that of an electron, but what about the other? It was then that Dirac postulated the existence of anti-electrons, and that set the ball rolling for antimatter research. Antimatter has the same origin story as matter. Right after the Big Bang, energy was compressed to form particles of mass. And when a particle is created from energy, an antiparticle with an opposite charge is always formed, thus balancing charges. This means that after the Big Bang, equal amounts of matter and antimatter came into existence. And here lies the universe's greatest unsolved mystery. Matter and antimatter were created in equal amounts, so where is all the antimatter? And shouldn't we have come in contact with it eons ago and destroyed each other? How do we still exist then? One theory states that in the beginning, matter and antimatter were pushed in opposing directions, and as the universe expanded, they got further and further apart. So to us it seems like only matter exists in this universe, but somewhere on the other side. Though scientists haven't been able to find large amounts of antimatter out there. Yet. Another theory is that after the Big Bang, some unknown process occurred which caused an asymmetry in the balance between matter and antimatter, tipping the scales in favor of matter. Some estimates say that as little as 1/billionth more matter existed as a result. Upon mutual annihilation, it's that minuscule fraction of matter which survived, and it's that which constitutes everything we see around us. Studying and harnessing the power of antimatter could hold the solution to many problems we may face, and if breakthroughs continue in this field as they are today, pretty soon our lives will be reminiscent of modern science fiction.